Thanks, Mike, for the introduction. Thanks all for coming to my talk, Attacks as a Service with the DeRF. Fun fact about the tool, it originally was going to be called Attacks as a Service, but I feared that the acronym would not pass HR. And then I was going to call it the DERP, Detection Replay Platform, but it's really not a platform, it's really more of a framework, and I just was worried about truth in advertising. So we have the DeRF, Detection Replay Framework. If I haven't met you yet, my name is Traxler, again, Principal Security Researcher, focusing on public cloud at Vector AI. I've got a couple of moonlighting gigs as well. I'm the lead author of the SANS Sec 549 Enterprise Cloud Security Architecture course, and I'm on IAN's faculty. If you know anything about me on the internet, you probably know that I have an extreme bias towards Google Cloud Security. So I'm here to introduce a new tool to you all, the DeRF, the Detection Replay Framework. But before we do that, I'm going to do a big rewind and talk about the existing tooling available to everybody. Talk about why that existing tooling didn't meet my needs, what use cases I was having for tooling, and really what was the impetus for creating the DeRF. I'm going to do a demo for you. I tried my darndest to get on the Wi-Fi because I really wanted to give you a live demo, but I mean, you guys are just hitting that DEF CON Wi-Fi too hard and it is just crapping out on me. So I'm so sorry, we have to do the recorded demo. But I have a recorded demo for you on how to use the tool. And then finally, we're going to look into the future and see what's on the roadmap and how you can extend the tool for your own use. This to me is the most important question of any new tool that comes out. Why in the world would you create yet another cloud tool, right? If you want to rewind back in history, you know, there was a long drought of cloud tools. As our industry matured, then Pacu was released 5 years ago at B-Sides LV. Since then, you know, probably a dozen tools are released every year. We have audit tools, we have attack tools, we have tools that spin up purposely vulnerable infrastructure. We have tools that are more like frameworks and modular components. We have tools that are just like handy dandy scripts. But there's one thing that each one of these tools has in common. All of the existing tools out there pre-assume that the person downloading the tool, administering the tool, setting them up is the same person who's executing the tool. That this download and execute is the same end user. This might not sound like a really big deal, like a big design decision, but it's been consistent throughout all tooling. And as it turns out, I came up with a ton of use cases that really needed a decoupling of tool administration from attack execution. So like I said, there's just a couple of use cases that existing tooling is built around. Somebody might build a cloud tool to be more of like an educational tool, right? Use this tool to understand how cloud attacks are executed. Or there's a ton of tooling out there for pen testers, right? You get dropped into an environment, a pen tester uses this tool as just a collection of helper scripts to help automate their boring work. Right, but most of the tooling is focused around this idea of a lone wolf, this like one person who downloads the tool and executes it. But in my job as a security researcher and detection engineer, I was hearing from my data scientists. They needed to execute my attack techniques in order to train their models, in order to train their algorithms. I wasn't going to be doing that. I was hearing from my developers who had code coverage concerns. They needed to make sure all of their algorithms were fully executed end to end, right? They had reliability concerns. I also had users who wanted to kick off detection logic testing to make sure all of the detection logic is tested end to end. We have a cloud detection, it kicks off as expected, it sends to the SIM and alerts the people appropriately. And finally, like many of you, I operated in a really guardrailed cloud environment with lots of controls. I needed to make sure that those controls continuously were tested and validated and then be alerted to say, oh, something that we don't expect to be able to happen actually is happening. None of the existing tooling met any of these use cases I was coming up with. All of them had this idea of the lone wolf and didn't have the concept of the decoupling of me, the attack creator, from the use cases of the attack consumer. So with this set of use cases was born the goal of offloading my work with the DeRF. It came with this very, very simple idea that I should be able to think of an attack idea, really quickly codify it, right? Just really quickly jot it down and publish it somewhere. From there, these diverse set of end users should be able to pull that attack and execute it at will, all operating off of the same source of truth. My use cases for an attack tool, my use cases for a cloud attack tool made it really sound like I needed the cloud to attack the cloud. Not only did I have a lot of personal satisfaction in this idea, it makes a ton of sense to use PaaS, right? For its reliability, for its scalability, for all the built-in IAM you get in the cloud, to use that to then execute attacks. So as I think I hinted, if you know anything about me, you know that I am a big Google Cloud nerd. So it's no surprise for you to learn that I decided to build my suite of attack techniques on Google Cloud. That's right. Even the suite of attack techniques targeting AWS, especially the attack techniques targeting AWS. I use Google Cloud to execute those attacks. The DeRF leverages Google Cloud workflows to describe API actions and then execute them in a defined order. So I'm able to define each one of my attack techniques in YAML. And most importantly, I have successfully sidestepped learning Go once again. As I mentioned, I really wanted to give you a live demo. The gods are not with us. I recorded one a few days ago just for this scenario. So what you're going to see right now is me executing an attack technique as a Google workflow, and then identifying the attack technique in CloudTrail, matching up the unique user agent and doing some correlation there. So it's about a 6-minute demo, me in my house. Let's see how the audio goes.
All right, I want to show everybody what it looks like to invoke another DeRF workflow, the AWS Secrets Manager Retrieve Secrets. Again, we can take a look at the source code by either looking at the source tab on Google Workflows or by looking at source code on GitHub to take a look at the attack description and see what this attack technique is doing. Here it says that this attack technique is going to enumerate secrets with Secrets Manager list secrets API. And then go ahead and it's going to retrieve the secret value one by one using the get secrets API. So it's going to call list secrets. And then iterate through all 20 secrets that are populated into this target AWS account and retrieve the values. We switch over to the infrastructure created in this module. We'll see that 20 secrets are created with the prefix DeRF retrieve secrets. And these are the values that are going to be retrieved when we execute the attack. All right, moving over to the workflows, we can retrieve secrets, execute. And as always, we can choose whether or not to execute this workflow as user 1 or user 2. I'll choose user 1, say to log all calls, and hit the execute button. And we have a success message from the workflow saying that this workflow was successfully invoked. I want to show you what it looks like then to grab these events from AWS and correlate it with the specific attack execution. So take note of this execution ID. This is the unique ID assigned to this invocation of this workflow in Google Cloud. It ends in B386. This value is going to be appended to the user agent for us to be able to easily identify it and correlate it in CloudTrail. We can even take a look at the attack workflow and see where that happens. We take a look at the get secret value. It's going to call get secret value in the Secrets Manager API. And the user agent that's going to send is DeRF-SM-retrieve secret equals, and then the execution ID of the Google workflow. So this is the value that we're going to be looking for, just to correlate that up to the box. Okay, switching over to CloudTrail. Remember this attack technique is making 2 API calls. First it's doing the list secrets, and then it's doing the describe secrets. The get secret value specifically. So I'm going to look for this get secret value under the event names. It might take a couple minutes to populate. Looks like this is the one that we did just a couple minutes ago. User 1, let's drill into this. Let's take a look at the user agent. And we see here the user agent is DeRF, SM's retrieve secret, equals, and then that execution ID that we were looking at that ends in B386. So that's a recap on how to execute a DeRF attack technique, but then also find the correlating logs by matching up the workflow execution ID.
Yeah, so the demo is a little anticlimactic, really. It's like pressing a button. Yeah, we'll press the button and attacks magic. So how is all of that mischief managed, right? If anything's too simple, there's got to be something under there, right? To give you a little idea of what's behind all of that, the backbone of this is deployed again in Google Cloud. What happened was when I pressed that button in Google Workflows, the attack was executed. All of the details of the API call to AWS were passed downstream to a proxy application. The proxy application then pulled the AWS access keys for whatever user I specified, user 1, user 2. Then in runtime, then it signed that request and then forwarded the request onto AWS. So all attacks sent to AWS are emanating from that AWS proxy application. Just like the proxy application, just like all of the attacks, all of the infrastructure that needs to be manipulated, all of this is managed by Terraform. It's all managed by one big apply, one big destroy. So let's say you have an attack technique that makes an S3 bucket public. That attack technique will make the S3 bucket public, and then with a kind of a background default user, it then reverts that change to kind of restage the infrastructure. How does it work in Google Cloud? Actually, it's a little bit easier, believe it or not, and not because I'm using Google to attack Google, but because they have a say in authorization system and use OAuth and make use of bearer tokens. So there's really no need for that silly proxy application. An attack operator presses the button on the attack technique, either presses the button as I showed on the console or programmatically hits it. Then the service account attached to the workflow impersonates one of two other service accounts in the target project, and then executes the attack in that target project. So the DeRF requires actually two projects, one for deployment and one for targeting resources. So as you might appreciate, there's a decent amount of infrastructure there to kind of manage all of this miracle. Fortunately, you can get it up and down really easily. Like I clock it under 2 minutes typically, 3 minutes if my computer's feeling hoggish. Deploying and destroying is really easy. I've been working on this for about 2 years, and I don't think I've had an AWS bill over $10 just leaving it up, and a GCP bill over $5 with thousands of workflow executions. So if you did just want to just deploy it and have it up and running, $15 a month is what you're looking at. And just a reminder, everything you need is with that apply command. So all of the attacker credentials, all of the workflows that codify your attack techniques, all of the target infrastructure. Probably the second most important question that I want to address after why the hell did I even build a thing is when to use it. I would say use the DeRF when you need a tool to manage your infrastructure for you. The DeRF is not a pen testing tool. It's not something that you're going to use when you get dropped into an environment. It has the concept of deploying all of the infrastructure you need to manipulate in order to generate detection samples, in order to test controls. And I will be saddened to hear if somebody's trying to use it on a pen test. It's just not, it's not the tool for the job, right? Also, use the DeRF when you need to test your controls, your org policy constraints, your SCPs, right? This is above and beyond something like Audit Manager that's going to be pulling your evidence. This is just like a continuous validation of testing your assumptions. Can I do this? I shouldn't. Can I do this? I should. Can I do this? I should. Let me know if it happens, right? And also use the DeRF when you need an extensible tool. You need something that's pretty much off the shelf that you need to then customize to your own internal needs. The DeRF comes with a ton of pre-built attack techniques. Give me about another week or so, and it should have attack parity with Stratus Red Team. So you can use Stratus Red Team locally and then execute those same attack techniques with the DeRF, right? But there's going to be a time when you need to build out your own internal test suites. This is really extensible. If you know YAML and you can follow some instructions, yes, you can. I'll just do a quick overview of the roadmap. Azure coverage. Currently the DeRF supports AWS and GCP. I will avoid the Azure coverage roadmap like the plague. If anybody wants to do it, let me know. It's on the docket, technically. I really want to expand out some attack techniques to cover CIS benchmarks. I think that'd be a really cool offering. And then I also want to have the ability to have automation built in. Currently, when you deploy the DeRF, you have to then configure your own automation, like Cloud Scheduler, to like automatically hit these attack techniques. It'd be really great if Cloud Scheduler like spun up on its own, and then you could say, yeah, run it at such and such cadence. So actually, that's probably the most near-term item that I'm going to tackle. But I don't think I have a ton of time, but I'm happy to take one question. 10 minutes, cool. Does anybody have any questions about it? Yes, sir.
Seems like so pretty cloud focused. Because infrastructure is really complicated, not everything lives in the cloud. Any plans to make it extensible to other types of attacks?
Yeah.
Network reconnaissance.
Yeah, the question is there any plans to make the DeRF target other types of infrastructure, perhaps network reconnaissance? If it can be invoked by an HTTP request, the DeRF is well suited to handle that. That's all the workflows are, is just describe what kind of HTTP request you would like to make. I don't think I will be doing that because I live in the clouds. I'm not coming down. But if somebody else wants to, it's set up to do that, absolutely. Anybody else? Anybody else? Anybody else? Yeah.
Is the DeRF open source?
The DeRF is open source. Gosh, did I miss that? Yeah, no, it.
Sound like it is. So.
Oh yeah, okay. It's available on GitHub. Please like and subscribe for sure. Yeah.
Is there use the repo?
Yeah. You know what? If you just go to thederf.cloud, that should get you started. Yeah, link to the repo, link to the docs, everything I talked and honestly a lot more about how to create your own attack modules, everything. So I'm excited to hear what people do with it. Anybody else? Yeah.
So kind of a newbie question. I've been a cloud developer for 3 years. I've been very new to security though. What are the life cycle of these attacks? Like if you make an attack, isn't it possible that the CSP could patch it or something? Like how?
Oh, the question is, what are the life cycle of attacks? If I make an attack technique, is it possible that a CSP could patch it? The attacks that we're focused on aren't exactly 0 days. They're just, features, not bugs, right? So, like I mentioned before, making an S3 bucket public, that's a feature, not a bug, but also maybe an indication that something's not right? So, that's not something that the CSP is ever going to patch, but it also could be a component of your threat detection in the cloud. Yeah. Yes?
Are there any detections you have now that you haven't found in any other tools yet?
The question was, do I have any detections in the DeRF that I haven't found in any other tools? Is that the correct question? Okay, so that's a really great question. I'm focused on first making sure that I have attack technique parity with Stratus Red Team, because I think it's really important that end users don't have to make a decision based on attack techniques to use tool A or tool B, right? Because a lot of times it's more about how does this tool deploy, what's its workflow, not about it has that technique or is that technique. I probably will be publishing some DeRF unique ones, but then I'll probably say, hey, Christoph over at Datadog, do you want to publish the equivalent of Stratus Red Team? I just think it's really good for our community to kind of just maintain parity along the tooling and just say, yeah, they're like commodities, right? Let's just have this commodification of it, and then we'll just have different tooling for different use cases. That's my theory anyways. Yes?
Do you think a use case for the tool could be validating security findings from other tools, like based on the outputs from other tools, validating if those findings are real positives, like trying to exploit those findings?
The question is, do I think that the use case for the tool is to maybe attempt to validate findings from other tools? Say, if a tool has one finding, the DeRF would go ahead and say, is this real or not? Maybe, so I tend to look at these, that sounds like a one-off thing. Like you want to just do a one-off thing. I would just use the CLI for that, honestly. And writing a YAML file is very easy, but it also suggests I'm going to be running this more than once, right? It also suggests like I have a reason to automate this or like disseminate it to a larger group. So ask yourself, am I doing this as a one-off, or is there a reason to kind of like publish this and have it automated? And that's kind of like the differentiator, or as I like to call it, the differentiator on why you would use it or not, right? Any other questions? Oh, hi, yeah.
Hi, so you mentioned earlier, you alluded to like the admin scenario, like, you need admin credentials to deploy, all that stuff. So for the data scientists and developers who are using your framework, what permissions, what RBAC do they need?
Oh, that's great. What permissions do you need to use it? Because all the attack techniques are executed with Google workflows, how you have access control around your attack techniques is Google IAM. So you give them the workflow invoker role. You can get that at the project level to say, hey, data scientists, hey, developers, you can invoke any of these attack techniques, or you can say, no, specifically, you can only invoke this one attack technique. That attack technique does not execute as them. It does not execute as the workflow. It executes as a couple users that they can specify as parameters. Does that answer your question? Okay, yeah. Yes, in the back. Oh, yep, you, yep. Mm-hmm.
Hi, thank you for the contribution. Really quick question, kind of related to what they're asking. We consider wrapping around the existing tool, like providing some additional features, such as a correlation is called CloudTrail, etc., but around the existing tool, so we can leverage what they have already built. But yeah.
The question was, would I consider like a wrapper around existing tooling to leverage what's already built? Did you have a particular tool in mind?
For example, Stratus, right? You mentioned.
Yeah, that's a great example. Yeah. So that's one of the reasons why I'm actually doing the conversion of taking, we have a Stratus Red Team module. I'm actually just converting that into a workflow. Takes me anywhere between 30 minutes to 3 hours, depending on if I run into a situation. So I just need to sit down and crank the rest of it out. I think I've got like 20 modules right now, and he has 35. So yes, I'm definitely committed to having the attack technique parity, but it's not a wrapper, it's a conversion. It's just we'll stay in lock sync, so we can just have consistency. Yeah.
You mentioned some of the motivations are detection, reliability, control, validation. Can you talk a little bit to the developer workflow, the detection engineering workflow, and how you kick this off sort of manually while you're developing a detection to generate the telemetry that you're going to detect on?
Yeah, the question was, can I talk to you a little bit about the workflow around, the use cases I mentioned? Like, a data scientist needs to train a model. Is that what you're thinking? And like a developer needs code coverage. Or, so you can definitely say like, there's CI/CD pipelines you can put in place that it needs to exercise a detection model, right? And those CI/CD pipelines are intended to exercise the entire code base, and the code base will then, spit out a detection. Depending on how you have that configured, is it going to go to somebody's UI? Is it going to send a Slack alert? Is it going to then go to a SIM? But you need a kicker for all of that, right? So they're generally like, it's like a kicker to a CI/CD pipeline. If that makes sense. We can talk more later. Yeah. One more question. Do you want? Oh yeah, hi in the back.
I know you talked about the correlation with the workflow ID. Do you have any like pro tips to kind of sift through like what was successful, maybe what was a failure when you're generating some of these events?
Oh, the question was any pro tip on sifting through what was success and what was failure when generating the events. All of the attack techniques I've written have pretty decent error messages that go through the HTTP response codes and will let you know it's a 400 and why it's a 404, this is why it's a 200, it's a success. So you should know based on the feedback provided to you when executing that workflow whether or not that attack execution was successful in whatever success means in that workflow. So it's built in. Yeah, okay. Catch me later if you have any more questions. Thank you.